नमस्कार दोस्तों। आज हम शुरू करने वाले हैं रिमोट सेंसिंग एंड जियोग्राफिकल इंफॉर्मेशन सिस्टम्स। ये बुक लिखा है एम अंजी रेड्डी, जो कि हैं प्रोफेसर एंड हेड सेंटर फॉर एनवायरनमेंट, इंस्टीट्यूट ऑफ साइंस एंड टेक्नोलॉजी, JNTU, कुकटपल्ली, हैदराबाद। तो चलिए इस बुक को आज पढ़ना शुरू करते हैं। तो ये देख लीजिए, ये हमारे सामने है कंटेंट्स, और कंटेंट्स में है मैप लैंग्वेज, फिर दूसरा है रिमोट सेंसिंग के बेसिक प्रिंसिपल्स, फिर है माइक्रोवेव रिमोट सेंसिंग, फिर है रिमोट सेंसिंग प्लेटफॉर्म्स एंड सेंसर्स, इसके बाद है विजुअल इमेज इंटरप्रिटेशन, राइट। इसके बाद आता है फंडामेंटल्स ऑफ GIS, ठीक है। इसके बाद आता है स्पेशल डेटा मॉडलिंग, राइट। फिर है GIS डेटा मैनेजमेंट, जहाँ पे हम लोग सीखेंगे फंक्शंस ऑफ DBMS, कंपोनेंट्स ऑफ DBMS, फिर डेटा इनपुट एंड एडिटिंग, फिर हम लोग सीखेंगे डेटा क्वालिटी इश्यूज, ठीक है। इसके बाद आएगा डेटा एनालिसिस एंड मॉडलिंग, फिर आएगा इंटीग्रेशन ऑफ रिमोट सेंसिंग एंड GIS, और इसके बाद आएगा अर्बन एंड म्युनिसिपल एप्लीकेशंस। इसके बाद आएगा क्रिएशन ऑफ इंफॉर्मेशन सिस्टम अ केस स्टडी। तो चलिए पहले चैप्टर से शुरू करते हैं पूरे जोश के साथ, और पहला चैप्टर है मैप लैंग्वेज। इंट्रोडक्शन की बात करें, द कलेक्शन ऑफ डेटा अबाउट स्पेशियल डिस्ट्रीब्यूशन ऑफ द सिग्निफिकेंट फीचर्स ऑफ अर्थ's surface has long been an important part of the activities of organized societies, ठीक है। From the earliest civilizations to modern times, spatial data have been collected by navigators, geographers, and surveyors, and rendered into pictorial form by mapmakers and cartographers. कितना प्यारा शब्द है rendered. Originally, maps were used to describe far off places as an aid for navigation and military strategies. During the 18th century, many governments realized the advantages of systematic mapping of their lands and commissioned the national government institutions to prepare topographical maps. These institutions are still continuing the mapping work. Many of the developing countries are making all attempts to obtain the status of a developed country. These attempts are based on certain strategies relating to areas like natural resource management and development, information technology, tourism development, infrastructure development, rural development, environmental management, facility management, and e-governance. In order to make an effective study of these thrust and emerging fields, new and innovative technologies have been developed. In the last 2 decades, innovative technologies have been greatly applied to experimental and operational activities. These technologies have their historical antecedents. For instance, remote sensing and GIS have been developed from earlier technologies such as surveying, photogrammetry, cartography, mathematics, and statistics. Laurini and Thomson, 1992, adopted the umbrella term geomatics to cover all these disciplines. They stated that the different aspects of each of these areas are necessary for formulating and understanding the spatial information systems. The traditional method of storing, analyzing, and presenting spatial data is the map. The map or spatial language, like any other language, functions as a filter for necessary information to pass through. Wow, wow, wow. What a wonderful line. The map or spatial language, like any other language. Wow, what a term, ladies and gentlemen. Spatial language. Function as a filter for necessary information to pass through. It modifies the way we think, observe, and make decisions. Maps are thus starting point in any analysis and are used in the presentation of results of any operational project. Whether it is remote sensing, photogrammetry, cartography, or GIS. The ultimate output will be the production of high quality, more accurate, and clearer map so that the user find it easy to make appropriate decisions. Therefore, maps and their production using modern technology is an essential starting point and they are necessary tool to explore the characteristics of spatial phenomena. This chapter is exclusively devoted to providing the fundamental concepts of a map, map scale, various terms used in mapping, review of map projections, and map symbolism. Map as model. The map constitutes the language of simple geography as well as automated geography. Wow. As a graphic form of spatial data abstraction, it is composed of different grid systems, projections, symbol libraries, methods of simplification and generalization, and scale. A map is the representation of the features of the Earth drawn to scale. The surface of the map is a reduction of the real scenario. Map is a tool of communication and it has been in use since the days of the primitive man who had to move about constantly in search of food and shelter. Wow. A map from any local planning agency provides different kinds of information about the area. This map focuses on the infrastructure and legal descriptions of the property, boundaries, existing and planned roadways, the location of existing and planned utilities such as potable water, electric and gas supplies, and sanitary sewer system. The planning map may not be of the same scale as the topographic map, the former probably being drawn to a larger scale than the latter. Further, the two may not be necessarily based on the same map projection. For a smaller area, the approximate scale of the data is probably more important than the details of the map projection. As Robinson et al. 1984 observed, a map is a very powerful tool and maps are typical reductions which are smaller than the areas they portray. As such, each map must have a defined relationship between what exists in the area and its mapped representation. The scale of a map sets limit on both the type and the manner of information that can be portrayed on a map. Spatial elements. Spatial objects in the real world can be thought of as occurring in four easily identifiable types, namely points, lines, areas, and surfaces. Collectively, these four features or various permutations and combination of these spatial features can form the human phenomenon or the spatial real world. Points, lines, and areas can be represented by using symbols to depict the real world. Surfaces are represented by any combination of these spatial entities. In general, all the geographic surfaces are in two tangible forms, namely discrete and continuous. Tree houses, road intersections, and similar items are discrete spatial features. A feature can be termed as discrete if it occupies a given point in space and time. That is, each feature can be referenced by its locational coordinates. All discrete features are said to have zero dimensionality but have some spatial dimension. Figure 1.2 shows the continuous spatial feature. The Earth's surface occurs all around as a natural features like hills, ridges, cliffs, trenches, which can be described by citing their location, the area they occupy, and how they are oriented with the addition of third dimension. All these are considered continuous surface features. These features are composed of an infinite number of possible height values distributed without interruptions across the surface. A topographic map depicts several kinds of information, both discrete and continuous. Elevation on site is portrayed as a series of contour lines. These contour lines provide us with a limited amount of information about the shape of the terrain. Different kinds of man made features, including structures and roadways, are typically indicated by lines and shapes. In many cases, the information on this map is 5 to 15 years out of date, a common situation resulting from the rate of change of land cover in the area and the cycle of map updates. Each of these different kind of information which we may decide to store in various ways is called a theme. A topographic map describes the shape, size, position, and relation of the physical features of an area. In addition to the mountains, hills, valleys, and rivers, most topographic maps also show the culture of a region, that is, political boundaries, town, houses, roads, and similar features. Okay. Next, we'll learn about important terminology of maps. The terminology used in describing any kind of spatial or geographic feature is discussed in this section. Elevation or altitude is the vertical distance between a given point and a datum plane. A datum plane is the reference surface from which all the altitudes on a map are measured. This is usually mean sea level. The height is defined as the vertical difference in the elevation between an object and its immediate surroundings. The difference in elevation of an area between top of the hills and the bottom of the valleys is known as relief of the terrain. A point of a known elevation and position, usually indicated on a map by the letters BM with the altitude given to the nearest foot, is termed benchmark. On same maps, the altitude is given along the contour line, Survey of India maps. A map line connecting points representing places on Earth's surface that have the same elevation is called contour line. It thus locates the intersection with Earth's surface of a plane at an arbitrary elevation parallel to the datum plane. Contours represent the vertical or third dimension on a map which otherwise has only two dimensions. They show the shape and the size of a physical feature such as hills and the valleys. A depression is indicated by an ordinary contour line except that hachures or short dashes are used on one side and the point towards center of the depression. The difference in elevation represented by adjacent contour line is termed as contour interval. Maps are a very important form of input to a geographical information system, as well as a common means to portray the result of an analysis from a GIS. Like GIS, maps are concerned with two fundamental aspects of reality: location and attributes. Location represents the position of a point in a two-dimensional space. Attribute at a location are some of measure of a qualitative or quantitative characteristics such as land cover, ownership, or precipitation. From these fundamental properties, a variety of topology and metric properties of relationship may be identified, including distance, direction, connectivity, and proximity.